Because I think you're understanding, Andrew, because I think you're understanding, I'm just going to sketch it out. I think it all makes sense. Now, so what you did, this is the midpoint. What you had done was you had sketched it so it was like, that. That does find your major axis. But that is not your ellipse degree at all. Your ellipse degree, you would determine by, like, if you look at, let me do it a little differently. If you envision the square underneath your, sphere, and in your case, you've got the light coming in like this. Well, if the light were coming in here, it would be 45 degrees. If the light were coming in here, it would be 0 degrees at the line of vision. Your light is coming in here about a third of the way, so that's a 30 degree. If it were coming in here, it would be 15 degrees, and so on. And so what you would do is you would say, okay, well, this is coming in at a 30 degree angle. So here I'm going to draw a 30 degree ellipse.
So you just knew what a 30-degree ellipse looks like and just put it in?
Yeah, because the 30 degree ellipse, remember, is the 1/2.
Okay.
So you would sketch that in. Now, if it were a positive 30 degrees, you would use this line. If it were a negative 30 degrees, you would just use this line.
Okay. And the reason why it looks like it's a little bit ahead in this one is because your light source is pretty close. Okay.
Exactly. If the light source were further away, if the light source were, say, over here where the projector card is, you would be drawing that ellipse here at the center point. Yeah, thank you, Carol.
So, would that work the same way if I have my light source coming from directly on top? Like, it wouldn't, so like, is mine incorrect too? If I did, like, because I did the thing where you measured the tangents and I thought that was like the shadow.
That is not the, that is not the shadow. So yeah, and you guys, this is exactly why we're doing a second day, because it's very, honestly, I gotta tell you guys, honestly, I don't think I asked your class this, but I asked the other two classes. I said, okay, you guys, on a scale of 1 to 10, with 10 being, oh, I own this subject, and with 1 being, I have no clue what you're doing, and 5 is somewhere in between. I was asking, well, okay, how would you rate your feelings about this? And most people were saying 5 or 6. And it's like, okay, even 4, like if you're anything above 4, you're doing great, honestly, because this is as dense as this material ever gets. This is the hardest stuff we're ever gonna do. I think it's harder even than aerial views and stuff like that. So if you're at a 4 even, or like if you're, oh, that's the mistake you made, oh, I used the tangent line instead and thought that was the degree, well, that's not a big mistake. That's a tiny little, that's a discrepancy we can fix easily, so yeah. Carol, sorry, Katharina?
I thought that we can't go beyond the center line, so my ellipse turned out to be really small instead of...
Well, you can't go beyond the center line.
Yeah, like the center line on the... that's parallel to the line.
Wait, can you speak up a little bit?
The line that's parallel, the one right beneath it. Yeah, I thought we can go beyond that, so my sphere turned out to be really small. Like my ellipse turned.
Yeah, you mean you didn't think the ellipse could swing down here? Yeah, see, and it can. Let me show you what I mean. So, this is their 0 degree, but I'm gonna now throw it over here. all it is. You know, now, it depends on, you do have to pay attention to it, this is where the logic comes in. You have to pay attention to whether the light's in front or behind of the object, because it determines which side of the ellipse you use to draw with, to draw the form shadow. But, yeah, it's, you guys are really doing quite well. I'm actually surprised.
Wondering, could you show how to do the shadow going up the wall there?
Okay, I can. I've got a couple reservations about that, and we're gonna get to that in a second.
So, you talked about
How would I, okay, you guys, do you remember how we did the glass ball?
Yeah.
Okay. Those two dots, those two white dots,
Yeah.
they're there and there.
Really?
Yeah, actually, hang on a second.
Or one of them is on the further side.
Eureka, can you hit the light? Actually, you guys, come back here for a second. Let's come back and just do this. And actually, this will look easier. All right, so you guys, so take a look at those two white highlights. Here's what they're dependent upon. Can you visualize them as imagine a vertical in between those two white dots that you're seeing. Imagine a line connecting them. That is the minor axis for an ellipse that basically cleaves through the sphere. Yeah.
But we would only draw the top one because our spheres are opaque.
Correct. You'd only be drawing the one. So like if I do, okay, actually here's an example. If I line it up like this, okay, I'm gonna do it.
Could we move this so it's like close so we can compare it?
Oh, good idea. Now I'm gonna do something for you. I'm gonna try and line up those two white dots for you. Okay, close one eye. You see how they're almost in the same spot? Okay. Now, for like Mads, close one eye. Okay. You see how they're almost in the same spot? Okay, for someone over here, like say Elizabeth, and if you guys aren't quite where this person is, you know, close one eye. Okay. You see how those two white dots are almost in the same spot? Now, so what I'm doing is at that point you have a 0-degree ellipse. At this point you have a 90-degree ellipse going through that, if those two white dots represent the minor axis. So like here I can put them as far apart as I can get, actually, like right there and there. All right, now let me try and answer your question a little bit about the sphere going up the wall. And this is where it gets a little bit challenging. Do you guys see, let's do this conceptually. You gotta love conceptual art. This is what I mean by conceptual art. Do you see that if I put the light here and I aim it at the wall, do you guys understand that I'm gonna have a circle? Okay, because this surface, whoa. So no matter what I do, this is going to stay a circle, but now watch, I'm going to turn it into, I think, a 30-degree ellipse. Watch. Because now the light's at a 30-degree angle to the wall. You follow me? That's exactly what I was showing about the surfaces, yeah.
Cause like I tried making it go off the wall, and what it ended up doing was making it stretch weird on the wall where I was not.
Okay, now this is what I wanted to show you guys. So like if I go like this, let me put it carefully near the edge.
You don't like the paper.
No, I kind of want it just to be unencumbered. So if I go like this, the cast shadow is, 0 degrees, or I'm sorry, 9 degrees. If I were able to go physically into the table, I could make it into a flat line, right? But now watch, if I go like this is like a shallow, this would be a shallow ellipse. The plane, for this plane, the viewing angle is like 10 degrees. So this is a very long 10-degree ellipse. But you see that that's circular? Because of the difference in the angles. Now, like if I sit it like that, this wall is perpendicular to that light angle. This wall is a grazing angle, so you've got like a 5-degree ellipse. Do you see how weird that is?
So like if we were drawing them, it'd be like this little stick of like this on the wall.
Well, yeah, but actually we can do it. Actually, let me do it with, it'll show better with this one. Do you guys see how shallow this is? But then poof.
So is that two shadows or?
The way I would think about it, I would almost act as if you have one plane and draw that shadow, and then one plane and draw that shadow, and what you're gonna find is they're gonna meet right there and there. They're gonna intersect. So yeah, what essentially you would have oh yeah, a good idea. Actually, let's do this. Somebody, a couple of strong people over there, push the table up against the wall.
Just this one.
Push, push, push. Okay. Let's see, let's straighten it out a little bit. You guys give it a show. Okay, that's good. Okay. So there, you guys, it looks relatively normal, but you see that this is about a 20-degree ellipse, and that's almost a circle. But then as I go more extreme, do you guys see that this wants to be like a 5-degree ellipse, and this is still a circle? Yeah.
So like if the light wasn't straight on, like if you like moved it a little to the side, would that stretch the one on the wall?
Exactly what I was gonna show next. Do you guys understand what Maz was talking about? So what matters is the sum viewing angle. So for instance, actually you guys think about it this way. This is the way it makes sense to me, like when I was looking at this stuff in the last couple days, as a way to explain it to you guys. If I have a circle, imagine that's a perfect circle. So if I have a circle, you're seeing it as a circle, a 90-degree ellipse, or you're seeing it as a line, or at a 30-degree angle, which is what makes it look like a 30-degree ellipse. Okay. Now, this is like a projection in space. It's the same as a plane in space. Well, with this one, this wall's a plane too, it just happens to be physically real. But it functions the same as that piece of paper. So now if I go like this and I move the light, this is gonna be a 30-degree angle. If I move to a 30-degree angle, I'm gonna this is gonna become a 30-degree ellipse. Now, mind you though, it's in perspective. This is where I haven't, to be very honest, this is what I haven't quite figured out how to show you guys cleanly, is how to do the summation of the angles. But this is gonna become a 30-degree ellipse, which then you're gonna see in perspective as something different than a 30-degree ellipse. But watch. Do you guys see that, like right about there? It's about twice as tall, I'm sorry, half as tall as it is wide. That's a 30-degree ellipse, roughly. Does that make sense? Now, here's what I think is far more important than you guys, as a nerdy perspective teacher, I want to know exactly how to explain this cleanly, and I don't really feel that I do have a clean method yet. That's clean and quick, like that little ellipse trick I showed you. However, I want to know that. But what is more important for you guys in terms of your career is if you go to draw that, you understand that that's elliptical, and that means it's symmetrical, and that means it's curving in a balanced way. Like, if you have that sense of symmetry, that is going to do more for your drawings than anything else. Just knowing that, oh yeah, it's going to be kind of at an angle like that, you'll be able to fake it well enough that people won't know.
So since the radiation is still of this major axis will be the same as the direction for
Oh, this is cool. You guys, let me show you something, Katrina. You're asking a great question. I want you to notice that. Watch the major axis of that ellipse, of the wall ellipse. Notice that it's slightly angling down. Now I'm going to make it slightly angle up. Okay? Let's keep going. Oh, we lose it on the table. Hang on. Do you see that it's angling down, or it's angling up now? Here it's angling down. What's going on with that? What's happening is this. Actually, let me do it like this. Do you see it's pointing straight down now? What's happening? What's happening is it's pointing to the radiation point for the light on the wall. Watch, let me show you. Every surface that has a, actually, Eureka, could you make sure this is in the notes? Every surface has a radiation point. Every surface that has a shadow on it has a radiation point. So like if I go like this, you guys look at the cast shadow for this object, and look at the cast shadow for this object, these poles. Notice where they're pointing. They're pointing to a radiation point directly above the light on the ceiling. Now, if I do this, let's see. Actually, let me do that. You guys, look at this. Look at the shadow on this thing. Look at the radiation points. Stay right, like there and there. Do you see how they're pointing to this spot? Now watch. Sort just walked by going, oh God, John's at it again. And now watch. You see what I mean? So, now, with that in mind, look at where the major axis is pointing. It's pointing to right there. But now what's always true what's always true is no matter what I do to this shadow stays elliptical. Unless I make it circular. And that's only when it's a perpendicular angle. Yeah.
So when I was doing the mechanical shadow, like if I tried to map it, it would do this like kind of warp thing. So are we supposed to just like map the half closer to the circle and then reflect it?
I'm going to show you guys a trick. When I was lecturing to the Tuesday class. You guys, this is going to sound a little bit schizophrenic, but it really isn't scary schizophrenic. It's just normal schizophrenia. Whenever I'm presenting, or whenever I'm watching someone present, ever since I became a teacher, I tend to do two things. One, if I'm watching someone present, I'm thinking of it as like, okay, what can I steal? Like what, I'm watching how they present as much as I'm watching the material. And then when I'm lecturing, a lot of the times I'll be lecturing and I'll be thinking, okay, yeah, you guys do this, and in my brain I'm going, now what is it exactly that I'm doing? Oh, I'm doing that. Oh, okay. So I was doing this yesterday in class, and I realized I was drawing the cast shadow ellipse, and I told the TA to put it in the notes as the quadrant method. Let me go ahead and show you guys that. Can somebody, let's